Hi guys, in this video we're going to continue looking at kinematics. We're going to start by looking at the 4 kinematics equations. This being a review series, I'm not actually going to work out problems involving the equations. Rather, I'm going to talk about the applications of these equations on the AP exam. I just want you to know that the first 3 equations are actually on the AP exam formula sheet. The 4th one is not, but I recommend that you memorize all 4 of these. That way you can work through kinematics problems quickly and identify relationships easier. So there are 4 kinematics equations with 5 variables: velocity final, velocity initial, acceleration, time, and change in position. It's very important to remember that delta x is change in position, not just position. T is also change in time, but on the AP exam for equation sheet, T initial is taken to be 0, so instead of writing delta T, it's written as just T. The first equation is velocity final equals velocity initial plus acceleration times time. The second one is velocity final squared equals velocity initial squared plus 2 times a times change in position. The third one is change in position equals velocity initial plus half times acceleration times t squared. The fourth one is change in position equals half times velocity initial plus velocity final times time. In all 4 of these equations, acceleration is uniform. That means acceleration is a constant that is not changing. If you know 3 of the variables, you can figure out the other 2. So if you're given 3 of the variables, you can figure out all 5 without any doubt. So let's say, for example, you're given velocity initial, acceleration, and change in time. You can figure out velocity final from this equation. You can use velocity final, velocity initial, and acceleration and plug that into this equation to figure out the change in position. So now you know all 5. And on the AP exam, take note of words like starts from rest, stops. Those words give you very important information. For example, if an object starts at rest, you know that the initial velocity is 0. And if an object stops at the end, you know that the final velocity is going to be 0. So it's very important to take note of that. And objects in free fall have an acceleration of negative g. That's negative 9.81 meters per second squared. What I like to do is always write down the givens and figure out what the question is asking me. It's very important that you read through the question carefully and identify the givens and what the question is asking you to find. You don't want to rush through reading the question because you want to spend time on the problem. It's very important to know exactly what the question is asking. With the time constraint on the AP exam, you might not want to write down the givens, rather underline explicitly so you can identify what is given and what you're looking for. Now let's talk about projectile motion. It's actually quite simple. Let's say a friend is standing over here, another friend is standing over here. The friend throws a ball to the other friend. The ball doesn't go just in the x direction, it doesn't go just in the y direction, rather it travels in a path that resembles a parabola. And that's all projectile motion is. When something travels in the x and y direction. The initial velocity might look something like this. And it might be at a 45-degree angle with the horizontal. And given these, we can figure out the x and y components using SOHCAHTOA, like we mentioned in the last video. As I mentioned, projectile motion has x and y components. It's important to note that in the horizontal direction there is no acceleration. That means velocity is constant. However, in the y direction, acceleration is negative g because the object is in free fall. That means the acceleration is negative 9.81 meters per second squared. It's very important to remember this. On the test, most of the time you will not be told. You have to know that objects in free fall have an acceleration of negative g, which is negative 9.81 meters per second squared. Always remember that. And what connects the x and y components are the time. And delta t it's a scalar quantity, and it connects the x and y components. If an object is traveling solely in the x direction, then there is no velocity in the y direction, and vice versa is also true. It's very important to remember that. And using this acceleration, and after you resolve the velocity into its y component, you can use the kinematics equations to figure out delta, the change in position, or whatever else you're trying to figure out the final velocity. But keep in mind, if you do plug in the y component as initial velocity, you'll get a y component of the initial velocity out. Then you might have to use SOHCAHTOA to figure out the resultant again. But in the y direction, however, this is a point where the velocity changes from positive to negative. So if you were to look at the velocity versus time graph, you see that it's v against t, and then you see that at this point the object goes from a positive to a negative. At this point, the object's going from a positive velocity to a negative velocity, and the velocity is 0. So the velocity in the y direction at this point is 0. It's very important to keep that in mind. Some problems will test that, and in many cases it's qualitative as opposed to quantitative, so it's very important to keep note of that. And that sums up what I wanted to cover for the kinematics part of the AP exam. If you have any questions, don't hesitate to comment below. If you haven't already, like the video and subscribe to our channel, and share the video with anyone that might benefit from it. Until next time, take care guys.